All right, here we are. Okay, so we have teased this idea that the investment questions we've been doing have not been quite realistic. For example, um, we saw for a grade 9 student to like save up, say, $10,000 for college, a car, university in like 4 years. They needed to invest like between 7,000 to 8,000 when they're in grade 9, which is not realistic. I don't know many grade 9 people walking around with that kind of money. Maybe you guys do. Um, what happens in reality more often is that we start with nothing and that you just put little bits away over time. Like you work at a job, you put a bit of your paycheck away every week, every 2 weeks, every month. So we're going to do an example by hand that shows this idea. And then we're going to transition to using the TVM solvers primarily. But here's the scenario. Grandma gives you $100 at Christmas. And instead of blowing that money on Robux, you're going to invest that money for 5 years. Every year you get that $100, you're going to deposit it. So let's track this money over time. So at the end of year one, at the very, very end of year one, or in year one, um, well, year one, you start year one with zero because it's at the end of the year at Christmas. Granny gives you some money. So if you start with nothing, the interest on that, if you multiply that by 0.6, is also nothing. But then good old Granny at Christmas time gives you that $100. At the end of year one, you have $100. Yay, you. So in year two, you start with, and we'll do this table to completion. It's only a few lines. It's not so bad. Year two, you start with $100. The bank gives you 6% interest. We can do the mental math with this one. So with interest, that grows to $106. But here's the new thing. Instead of that initial 100 just getting interest, we're now going to add on another 100 in the middle of this 5 years. So add on another $100. We now have $206. And now in year three, we have $206 to get this interest. So can you guys, for the next 3 years, this isn't overly complicated, find the interest and add it on by multiplying by 1.06, and then add the $100 that Granny gives you, and then we'll see how much we have after 5 years. A bit more of a realistic savings scenario. I'll do it along with you guys. $1.06. I won't pause the video either. We'll just all suffer together and do these calculations. So 218.36 after we get interest, but then Granny gives us some more money. Add on 100, 318.36, which is what we start the next year with. I'm not going to do any rounding. I'm just going to keep everything stored on my calculator to be as accurate as possible. If you've been doing rounding, if you're already past year 4, year 5, just keep doing what you're doing. We're only going to differ by a few cents, if at all. Plus 100, and then that gets multiplied by 1.06. I know this is a little tedious, but it just gives you a good idea of what's happening. We're going to use the TVM solver to do this momentarily. I got 337.46, and then Granny gives us some more money. Start the next year off with that. And then one last time, we will multiply that by 1.06. $463.71. Thank you, Granny, for the $100. $563.71. I see people done. Did you guys get that too? Okay, perfect. Now, that's a good illustration of what happens when we regularly deposit money over time. This series of deposits is called an annuity. So there's additional terminology to annuities. Maybe some of you guys will get into finance and talk more about these. But this is the scenario we did here is also a simple and ordinary. Those are two separate terms. Those are simple and ordinary annuities because we're depositing the same thing every time. We are depositing at the end of the year. And that makes this a simple, ordinary annuity. Because we know in real life, I could put in $100 one year or $120 another year, and that can be flexible. The interest rate can change. I can put it in on December 20th instead of December 30th. A lot of things change. So to keep things simple, to keep things ordinary, it's the same amount. It's at the end of the period. This is called an annuity when you save, make regular deposits over time. Now, we don't want to use a table all the time. Like if you guys can imagine, let's say planning for retirement, you start a job, you work for maybe 40, 45, 50 years, I don't know, and you put a certain amount away every month. Do you want to do a line like this every month for 50 years? Very impractical. So I'm going to train you guys on how to use the TVM solvers to do this. So we just did a table. I'm going to show you guys how to use the TVM solver. Now, there is a formula, like a compound interest formula, for calculating these future values for annuities. It's in the 3U course. I might tie in this formula. I'm not sure yet. It's not important to grade 12 at all. For the 3M students, the curriculum says you just need to use a TVM solver. So here we go. Let's actually solve this problem using the TVM solver. There's a difference between what you guys were doing yesterday and today. When you are doing annuity problems, our N isn't going to be years anymore. It's going to be how many deposits we make. Now, it just so happens with the granny question, because we're making yearly deposits, we still make 5 deposits. It is 5 years. But I'm going to be keeping this prompt here for you guys that for today, that capital N is how many deposits we're making. I is the same thing as yesterday. You just put in the whole percent. PV, how much did we start with in this question? 0. So this is new. Unlike yesterday or the day before where you start with something and we get interest on that something, in these saving questions, we're going to assume that we start with nothing. Here is where we're going to make use of our PMT. PMT stands for payment. And because we're investing $100 every year, that deposit amount, we're going to pop in. And we're going to put in minus 100 because you're giving that money away when you invest it. So we are looking for FV. We're looking for how much we'll have in 5 years in the future, a future value. And then this is where we'll also make use of our PPY. In this question, how many deposits per year were we making? 1 deposit per year. And our interest was also calculated annually. So what you guys will notice for all of our work, literally all the time, PPY and CPY, that sounds dirty to say, PPY, are always going to match, always. Now, I believe your TVM solvers, if you change PPY to say 12, on the Inspires anyway, it will automatically change CPY to match it. Those two things are always going to match, okay? So if you guys pop those in, I'm going to cross my fingers that this works actually. I'm 96.3% sure we're going to get the same answer we got in the table. We should. Pop those in and solve for FV. Of course it's going to work. Tab button's your friend if you're doing if you're on the Inspire. Also, if you're on a computer, if you're using your phone and you don't have a tab button, sucks to suck, I guess. PMT minus 100. We're going to solve for FV. All right, I'll wait a second. you guys to catch up. People at home, you should be doing this too. Have your TVM solver loaded up. All right. And 563.71, which is what we got, right? It works. You guys convinced it works? I would rather use a TVM solver than do a big table like that. So we'll pop in our final answer. If you're doing an assignment for me or something, you would put your best foot forward and write a concluding statement. You know what? I'm a role model here. I'm gonna set the tone. I'm gonna make a therefore statement with my therefore symbol. You would have 563.71 in 5 years. Okay, so a very useful type of question, because now we can start doing more realistic savings problems, and you guys can even now start planning for your future. We're going to do a few, 3 or 4 examples together that I think are pretty useful, applicable. Let's try one. I always like to do this first one. I remember this one when I was in grade 7. I remember some person from some bank came to my school back in Elora and actually did this $1 put away every week for 50 years. And it was pretty fascinating how much you earn. But let's give this a try. So we want to find how much money we would have if we invest $1 for 50 years. So let's walk through one by one what we're punching in. Here we are investing $1 a week, and interest is calculated weekly. So our N isn't 52. Or sorry, it's not 50. N in this case is how many deposits we make. It's 50 times 52. Now on your Inspire, I believe you could literally type in 50 times 52 in that field, and it will do it for you. Of course, we all have a regular calculator to do that as well. But I believe 50 times 52 is 2,600. It is. So 2,600 deposits of $1. Okay? So remember, it's number of deposits. We're doing 12%. 12% is pretty generous for an interest rate, but if you're not touching it for 50 years and part of your investment is maybe gets into the stock market, a mutual fund, that's not unrealistic. PV, we start with nothing. PMT, we're putting $1 away, minus 1, because we're giving it away. We're solving for FV, circle it, and this is a weekly question. So PPY, don't giggle, PPY, and CPY, 52 and 52. And let's find out how much we would have in 50 years. Just $1. $1 a week. All right, I'm going to come along for the ride here. Now, just out of curiosity for people using this, I'm just going to see, does this actually do the multiplication for me? It does. That's neat. Okay, it does the multiplication. We are using 12. PMT is -1. And then we're using 52 and 52. Solve for FV. This looks familiar, as I have done this question probably 40 times in my teaching career. Did you guys get 173,000, blah, blah, blah? Wow, let's write down that number and then talk about that. 173,000. I'm old. Oh, I already forgot the decimals. 181.50, 181, what are you? 181.55. 181.55. 173, 181.55. That's quite a lot. You might be thinking, hey, so what? That's 50 years, and that's a lot of deposits of $1. That's maybe that you think that's a lot of money. Let's do a little comparison. How much money did you deposit in total over those 50 years? So I'm going to be asking you guys to do this in our performance task when we plan for retirement, I'm going to have you do calculations like this of our own money. So we made 2,600 deposits of $1. So obviously in this question, that would mean we deposited over the course of these 50 years $2,600 of our own money. But in general, I'll just add in brackets here. In general, you would just multiply how many deposits you made times the deposit amount, okay? But I think we all understand 2,600 times 1 is equal to 2,600. Now let's find out how much interest did we make? How much free money did we get just by putting $1 a week away? Well, to do that, we take our future value, which we had was just slightly over $173,000, and we just subtract how much of our own money we put in, which was $2,600. I mean, most of that future value is interest, but it's interesting just to calculate this. 73, 181.55. $170,000 and then some change. 581.55 in interest, in free money. I think that's pretty interesting. And that's just $1 a week. And I think $1 a week, I know many of you guys work part-time jobs. Like I think minimum wage is roughly $16 an hour. I'm not sure, around that for students, I think. I think $1 a week is pretty manageable. And you know what the interesting thing, a useful thing with TVM solvers is you can make changes on the fly and have immediate updates. So for example, what if you doubled it to gasp $2 whole dollars a week? If you could sacrifice 37 less Robux and put in $1 extra a week, how much would you have in 50 years? You just literally change PMT to -2 and re-click on FV, and now we have almost $350,000. So very, very cool. And what about $5 a week? We're probably close to a million. Almost a million, 865. So very cool. We're going to do a retirement planning question in a second, but there are people that work at banks who meet with people who literally are just glorified TVM solver users. They sit at a computer, they bring their clients in, and they just use a TVM solver and like spit out a bunch of, hey, if you did this, this, and this, here's how much you'd have in 50 years. So you guys are now qualified to work at a bank. You guys can use a TVM solver. We have an online one. You don't need to buy a TI Inspire I'm not even sure where you'd carry that on your person. But yeah, this is what people at a bank do. You guys can do it. All right. Very cool. Let's do another example. Let's maybe make this even more applicable. You guys are close to starting your working careers. Let's do a retirement planning example. So we're going to bump it up. This isn't a dinky $1 or $2 every week. Good old Jim is going to invest $300 every month into a retirement savings plan. We're going to find out how much he will have when he retires in 40 years. Now, you'll have to forgive me. This question, we're investing every month, but I lied and said the interest is compounded annually. These all have to match all the time. Now, I've been doing this question a long time, and I still haven't fixed it, and I'm probably not going to fix it for next year. So we'll just leave it as monthly again. Okay, but this is what you guys have to get used to. Obviously, your TI Inspires, it's pressing a few buttons. We have to make sure we're setting it up correctly. N is not 40. He is retiring in 40 years. N is the number of deposits. How many deposits will Jim make over his working career? It's 40 times 12. Why 12? Because it's a monthly question. He's depositing monthly. 480. Yeah, and you guys are getting pretty pro at this, so I don't think we need to take as much time setting them up. I is the interest rate. We're starting with nothing. PMT, he's investing $300 every month. Okay. We're looking for how much he will have. And this is a monthly question. So PPY, CPY, 12 and 12. Let's find out what he has. And let's do a calculation to show how much interest, how much free money the Jim made just by starting to plan for retirement early. Super useful stuff. All right, we'll play some catch up here. 480, 7.2 minus 300. Looking for that monthly. Oop. Solve for FB. All right. That is not a typo. I don't think anyway. I got 833,000 and change. You guys get that as well? Oh, blank stares. Or some slow nods? I can't tell. Okay. You guys got this. Okay. Let me jot that down. 833.01. No, I already forgot. 833 anyway. 833, 81.43. 81.43. 81.43. All right. He will have, again, I'm going to be a good mentor today and write my therefore statements. He will have, wow, close to $1 million in 40 years. That's not too shabby. Now you might think, well, you know what? That is a lot of money, but $300 a month is also a lot of money. That is a big sacrifice. Well, we can make an apples to apples comparison here. How much did Jim deposit over those 40 years? Well, he made 480 deposits of 300. Well, how much is that? Well, we can find out. Just multiply on your calculator. 480 times 300. $144,000. Yes, that was a lot of money. That is a lot of Robux that he could have, if he wasn't patient, he could have got a lot of Robux over those 40 years. But he was patient. He invested that money, and the free money that he made, I mean, just doing the mental math, it's going to be over $600,000 here. Just do a little subtraction. I'm not going to try to do the mental math there. 81.43. Wow. In interest, almost $700,000. $689,081.43 in interest. Okay, and this isn't like just abstract. This isn't going to be useful tomorrow. This is like the math of real life. When you guys start working, if you just start planning early, it can really add up over time. And that's 40 years. You could work longer, you could work less. I don't want to steal too much thunder from tomorrow, but like most people when they retire, like Jim has over 800,000 here, he's not going to just take all that money out of the bank and just like blow all his money. He's going to leave that in the bank. It's going to continue to earn interest as he grows old and lives off that money. Tomorrow, we'll do some more calculations for how he can stretch that into even more. Now, I have told you guys, don't write any of this down, but the great thing about TVM solvers is you can make adjustments. What if he could find an extra $20 a month? You can just update your PMT and resolve an extra $50,000 in the end. I'm not joking. People get paid just to use a TVM server all day. This could be you. You might have to buy a tie or like some dress pants or something. But this could be you. Work at a bank, use a TVM server all day. Okay. I joke a little bit, but it's kind of true. All right. There's another kind of thing I want you guys to be able to do with these kinds of questions. Another scenario is, this is Joe Smith, I guess, because he's Mr. Smith. So Joe Smith wants to have the same amount saved up, but after only 30 years. what would he need to invest each month? So this is a bit different. In this question, he has a saving goal. So we actually know the future value, 833.01.43. But he wants to know how much he would need to invest each month. Guys, in this question, we're starting with a goal and we want to find how much you have to put away each month. But it's the same thing. It's you punch in what you know in your TVM solver and you click on what you don't know. So this is 30 years. So we're changing the deposits. 30 years of monthly deposits, that's 360. But everything else stays the same. It's still 7.2%. It's still PV is 0. PPY is still 12. CPY is still 12. So this is a second kind of question I want you guys to be able to do. We have lots of time, so I might actually do one more question with you, but we won't write it down. We'll just kind of play on the TVM solver. All right. Okay, so we have that old FV. We're just changing N to 360. So obviously he's working shorter, so we expect to see a larger deposit amount. And yeah, just to work 10 years shorter, his deposit amount more than doubles. Did you guys get that too? That's fascinating stuff. IMO. It means, in my opinion. 656.37. Let's jot that down. It's negative because we're giving that away. 656. I cannot remember the cents. 656.37. He would need to invest $656.37 each month. So I can make this applicable to you guys. So let's say you start working, whenever that is, after school, out of high school, whatever. And you're like Jim Smith and you put in your $300 a month for 40 years and you have $833,000. But let's say instead, when you start working, for 10 years, you spend, I joke about Robux, but let's say you spend, you party, you travel, and maybe you do a few of those lavish things, but you don't save up any money for retirement. It takes you 10 years to come to your senses and be like, okay, maybe I should start saving for retirement. If you wait for 10 years to have that same amount of money saved up when you retire, you have to do like 656. That's more than double. Start early, and it's just start early. Maybe this is a good conversation with parents. Hey, when did you guys start? I'm lucky. My job forcefully takes out money for my pension plan automatically off the top. I don't even have to think about it. But many of you guys will have to do this like independently. So please do it. Can I show you guys one more thing we can do? And you don't need to write this down. But same scenario. Let's change things back to the original. Let's say PMT. Let's say $300. $300 a month is what you can afford to put away. But let's say you want to have $2 million saved up. You want to be a millionaire times 2. A realistic question is, how long do I have to work in order to have this retirement savings goal? So if this was a how long do I have to work question, what do you guys think we're going to be solving for? How long do I have to work? We've solved for PMT, we've solved for V. If it was how long do I have to work? N, exactly. But so you put in $2 million. I got to count my zeros. 1, 2, 3. You put in your FV and you just click on N. 620.78. That's months. Remember, this is months, right? Monthly deposits. Well, how many years is that? I'm kind of feeling bad for Jim Smith right now because I think that's a lot of months. You know what? No, it's not that bad. 620.78. Just divide that by 12. That's 51 years. So, I mean, he'd have to work for 51, 52 years to have $2 million saved up. But like, you can do all kinds of things. You don't need to hire a retirement planner. Actually, you guys should become retirement planners to scam people out of their money, because they can do this themselves, but no, you're going to get them to pay you to punch numbers in a TVM solver all day. All right. So I hope that you guys found that useful. A new type of problem. I have 7 or 8 questions about annuities to do. Just get used to using TVM solvers. You could also use this time to wrap up the thing from yesterday, because we're moving on tomorrow. We're doing another thing tomorrow. Annuities practice for you guys. I have the numerical answers on the back, so you can be comparing as you go. Try these. Yeah, just make sure you try some of these. Get comfortable using the calculators. If you've got a problem, you can do it. Yeah, for you. And I'll let Richard on. And the video